All right, so I'm hoping that you've already kind of taken a moment to try to fill out this quadrilateral family tree on your own. If you haven't, please do that because I think it'll help you more than just hearing me go over it. But here are what your answers should be. Right? We should have parallelogram, kite, and trapezoid. Those are our three big branches, right? And then the parallelogram splits into rectangles, rhombuses, and squares. And hopefully a lot of this is familiar from when we did quadrilaterals earlier. That rectangles and rhombuses, right, they get everything from a parallelogram plus more specifics, and a square gets everything from this family, right? Kites and trapezoids are kind of their own thing. That's what this note at the bottom is also confirming, that there are some mathematicians that prefer an inclusive definition of trapezoids, where they talk about how it's at least one pair of parallel sides instead of just exactly one pair. We're going to use the exclusive definition up here of exactly because we want to make sure that we're distinguishing between trapezoids and parallelograms. So you can go with this definition here. The back of this worksheet is also going to be super helpful when we're doing these proofs because it's kind of just a summary of everything that we've been talking about. So we've got parallel lines, perpendicular lines, their criteria at the top, the formulas that we're going to use. Also, you can see at the very top of the chart is triangles, which we just kind of wrapped up, where it kind of says that to prove that a triangle is a right triangle, you got to use the slopes to show that two sides are perpendicular. To prove something about the side lengths, we're going to need to do distance formula or Pythagorean theorem. And then I kind of laid out for you the main ways to prove each of the quadrilaterals. So I want to highlight that in this middle section, you're really only required to prove one of these. So if I wanted to prove it's a parallelogram and I prove two pairs of opposite sides are parallel, I am good. It's a parallelogram. Now, I don't know if it's, in addition, a rectangle, rhombus, or square, right? These are all parallelograms, but I've proved kind of the basis for it being some type of a parallelogram. And then on the right, it kind of corresponds with what you would need to use, what formulas or concepts you would need to use to prove this statement. So it kind of breaks down into rectangles, rhombuses, squares, trapezoids, and kites. So keep this handy, and we're going to use this kind of in class as well to guide us through these proofs to get started. So let's do a proof. We're going to start off with just the slopes and lengths already given to you. Okay. So for instance, I want to classify quadrilateral bear, where I know these slopes and I know these lengths. And I've written down kind of the different quadrilaterals over here. You can do the same because we're going to kind of go through a kind of a mental checklist based on these criteria. So the first thing I want to do, because I want to visualize what bear is going to look like, I'm just going to kind of draw a generic quadrilateral and label it BEAR. That's just going to help me be able to see, am I talking about adjacent sides, opposite sides, right, when I'm looking at these criteria. So if I look at this, if I look at my slopes, I can see that I've got some equal slopes, which shows me parallel sides. Well, BE and AR are equal slopes and they're opposite sides. So these opposite sides are parallel. In addition, EA and BR also have equal slopes, so these sides are parallel. Well, if I know that opposite sides are parallel, it's some type of a parallelogram. So it's one of these top four. Can't be a kite, can't be a trapezoid. Also, I'm noticing that I'm seeing 1/3 and -3. Those are negative reciprocals. That means that BE and EA are perpendicular. And that's actually true for all of these adjacent sides. So I've got all 90-degree angles. Well, of the parallelograms, only rectangles and squares have 90-degree angles. So I can cross off parallelogram, I can cross off rhombus. And to figure out if it's a rectangle or a square, I have to look at the lengths. All the lengths, all the sides are congruent. Therefore, it is a square. For oh my, I'm going to again draw my little kind of square looking thing, even though I don't know if it's a square yet. Oh my, right? Again, the letters have to go in order. And here I'm going to start by looking at the lengths, because you could do that as well in your thought process. I can see that OH and MY are congruent, HM and OY are congruent. Well, opposite sides are congruent. That's another way to prove that something's a parallelogram. So I can again cross off kites and trapezoids. But I can also see that not every side is congruent to one another, right? Not all four sides are congruent. So that means it can't be a rhombus, it can't be a square. And now I'm left with two, and I look at my slopes and I see, Well, I see parallel sides. That's good. That confirms that it's a parallelogram. But I don't see negative reciprocals. I see reciprocals, but they're not opposite signs. So there's no 90-degree angles here, meaning it can't be a rectangle. So I can conclude that it is a parallelogram. So that's kind of the thought process I want you to be going through when you're doing these proofs, is kind of, what do I know about slopes and lengths? How can that narrow down my classification? So let's do it for an actual proof. So on your paper, you're seeing a picture here. Okay? You're probably thinking, that looks like a kite. I would be thinking the same thing. Now, to figure out the slopes and the lengths, just like for all the other triangle examples we did, I like to draw in kind of these right triangles to help me. So you can do the same on your paper. So you can kind of see already AD and AB are going to be congruent because they have the same sides of these triangles, 4 and 1. Similarly, DC and BC are congruent because they both have 5 and 8 as their side lengths. But let's write all of that down. So you kind of want to always set it up so that you have slopes, lengths, because you're going to need both. So I know I'm moving fast and you'll have to kind of copy these down as we go, but the slopes, right, are for AD is -1/4, because I'm going down 1/4. For DC, I go down 8, right 5, -8/5. CB would be -5/8, and BA would be -4. So what does that tell me? Well, just looking at those slopes, right, I can already see none of those are equal, none of those are negative reciprocals. So that's also kind of confirming my idea that it's going to be a kite. And then for the lengths, right, I can use Pythagorean theorem. 4 squared is 16 plus 1 squared is 17. So these two both are square root of 17 units. DC and BC, 25 plus 64 is 89. So these are the square root of 89 units. So I'm a bulleter. I like to just bullet my thoughts and kind of do my mental checklist at the same time. So the first thing I noticed from these slopes, right, is that I don't see any parallel lines. None of the slopes are equal. None of those slopes are equal, meaning there are no parallel sides in A, B, C, D. Well, if there are no parallel sides, I can already cross off the majority of these options. It is not a parallelogram, or a rectangle, or a rhombus, or a square, or a trapezoid. Now, that doesn't mean it's a kite, right? It could just be some generic quadrilateral. So we can't stop, but kite's really my only option left. So, but I found out something about the lengths. I found out that there are 2 pairs of adjacent sides that are congruent. And we're going to throw in that word, and it's on that reference sheet as well, that it's 2 pairs of disjoint adjacent sides. Disjoint meaning these 2 pairs do not overlap with these 2 pairs, right? These 2 sides and these 2 sides are totally separate. One pair, totally separate pair. So as shown by the side lengths, 2 pairs of disjoint adjacent sides are congruent. That confirms that this is a kite. Can't be anything else, and it's got that main characteristic of kite, so we're good to go. So what I want you to do is pause this video and do question 3. Question 3. And I'm going to flip in just a second and explain question 3, and I'm hoping that you already have it done so you can be checking your answer as opposed to just listening to me talk through it. And we're off. All right. So here's what your answer should or could look like for question 3. So we've plotted this. You might have already, after you plotted it, thought, looks like a square. You're right. It's going to be a square. All the sides have these same triangles, 6 by 8, 6 by 8, 6 by 8. That already shows me all the side lengths are congruent. They are going to have a length of 10 units. And if I go through and find all my slopes, IL and JK or KJ are down 8/6, so there's my -4/3. And these 2 other sides, JI and LK, are up 6/8, so they're +3/4. So the first thing that I kind of showed was my opposite sides are parallel, right? Because their slopes are equal. Also, all the sides are congruent. And finally, adjacent sides are perpendicular because the slopes are negative reciprocals. All of these -4/3 times 3/4 equal -1. And so those 3 things, right? This makes it a parallelogram. This makes it kind of a rhombus or a square in that mental checklist. And then finally, it's got to be a square. So finish up the